Okay, kids. Yeah, we're back here. We're into chapter 8. We're not going to do all of chapter 8. We're only going to do a few bits of it, and then there'll be a chapter 7, 8 assignment together. So don't worry about that. I haven't forgotten about chapter 7. So we're going to introduce you to music because you might think music is an art, and it is. It's a beautiful thing. But there's a connection to science and mathematics in music. And that's what we're going to take a look at. No one's going to learn to play an instrument after our lessons here, okay? So music is a combination of specific sound frequencies. And what they call these specific sound frequencies in the world of music is a note, a musical note. And it becomes a note uh, when it's pleasing to us. It sounds nice, this combination of notes. There's some pattern to it. The opposite of music is what we call uh, noise. All right. And noise is not pleasing. There's no pattern, uh, and it's constantly changing frequencies. Just, just don't know where to get your brain involved into it. That's noise. Now, let's talk about these notes a little bit more. These notes, these musical notes, have been arranged into what we call a musical scale. Now, the musical scale that we use is all based upon a musical note called middle A, and that frequency is known as 440 hertz. All the other notes are a multiple of middle A 440 hertz. For example, the next note is A sharp. So to get the frequency for A sharp, you take that original 440 hertz and you multiply it by the 12th root of 2. Let me rewrite this for you. The 12th root of 2, the 12's in here. It's not 12 times that. Or if you want to write it as a fraction, it's 2. I'm going to rewrite this to the 1/12th. If you put that in your calculator, you'll get 466.2 hertz. And we've gone to A sharp. If you want to go to the next note, which is B, the next note is B, well, you would take 440 hertz and you would multiply it by 2 to the 12/12ths. That's your exponent, 12, 2 over 12, for multiplying the 2 with that exponent. And you get 493.9 hertz, and that's your B note. The next note is C. You take that original 440 hertz and you multiply it by 2 to the exponent 3/12ths, and you get 523.2 hertz. Now, I'm sure they teach you this downstairs in music class with Mr. Good, but some of you don't take music, so we'll go over it. And that's C. And you get the idea here. C sharp, the exponent would be 4/12ths on the 2. And then 5/12ths, 6/12ths, all the way through these notes. A sharp, B, C, C sharp, D, D sharp, E, F sharp, G, G sharp, until you would finally get to 440 hertz. Let me put a Z in there. 440 hertz times 2 to the 12/12ths, which is basically 2 to the power 1, which is 2. So you'd be multiplying 440 times 2, and that gets you to 880 hertz. So you've, in essence, well, you have doubled the original 440. Once you've gone through this doubling, you may have heard this term before, you have gone through an octave. You're up an octave, you've doubled it. Because look, A1, B2, C3, D4, E5, right? Uh, F6, G7, 8 is when you land on the next A. That's why it's an octave. All right? Now, if you go and you take that original 440 hertz and you would cut it in two or multiply it by zero point 0.5, you're down an octave. So you can go up an octave or you can go down an octave. And this is how the musical notes are all arranged for us in terms of the musical scale. So it's kind of scientific there, okay? It's kind of scientific. Next, let's combine some notes together. Well, this is what we found, that some notes play nicely together. They combine nicely, so there's consonance. Sounds pleasing. And it's a combination of notes with simple ratios like 1 to 1, 2 to 1, things like that. Very simple ratios, right? You might be playing a musical instrument and then you have another musical instrument and they're both playing the same frequency. Or one is twice the other frequency. Very simple ratios. When they're played together, these notes, it sounds nice. That's consonants. Dissonance, diss, they're dissing your ears, does not sound pleasing. You're playing combinations of frequencies of musical notes, doesn't sound nice. And usually these are combination of notes, that's the word notes, right there, with complex ratios like 9 to 5, 12 to 11. They're not simple fractions. It's found that when you play these notes together, it doesn't sound nice. So here's your introduction to music. I've given you some reading to do and a nifty little video to watch on YouTube. All the links are in today's announcement. Hope everyone's doing well and have a great day. Bye-bye.